From grade 8, we've learned about equations, okay? We've just learned about general equations in algebra, where you'd have y is equals to x plus 3, something like that, or 0 is equals to x minus 3, and then you had to solve for x. That's just a general algebraic equation. The first one is two variables, and there's like a constant term. The second one, just one variable of x. We obviously understand what variables are. Okay, and then we went on, we learned about exponents, okay? We've learned about the power, we learned about an exponent, and we learned about, most importantly, what we're gonna apply is the laws of exponents, okay? We learned about the negative exponent, we learned about the power of 0 over and above the 4 laws, okay? If I summarize the laws very quickly, we have the first law there. You know, when you're multiplying powers of the same base, you add the exponent, okay? That would be the entire power. That would be entire power. That would be entire power, okay? The base is the same. That would be the base. That would be the base. Those are the same base. If you have those two conditions and you're multiplying, that dot obviously means multiply. We would add the exponents. As you see, the exponent m adds to m, okay? And then we went to law number 2. Law number 2 was that one. We said if you divide powers of the same base, okay, again, that's a power. That's a power, okay? And what's the base? The base is x. We would subtract the exponents, and as you can see, we're subtracting there, okay? Third rule is raising a product to a power. Okay, raising a power to a power. Sorry, you multiply the exponents there. You had x to the n. When you have this bracket, you see what happens to the exponents. It's n times m. Okay, that's what happens. And then lastly, the fourth rule is raising a product to a power. Okay, we've got a product of terms here. Okay, very important to note in exponential language is that is not part of the power, okay? That is not part of the power. You can call it the coefficient of the exponent, okay? That's the power right there. That is the power, okay? So that power, in any case, if you've got the bracket, you look at the exponents, you would multiply the exponent first into 5 and then into x. So you'd have n plus m, and then you'd have 5 to the n, okay? You distribute. Even if you had a variable here, you do the same thing. If you had a different variable, you do the same thing. But in this case, the number, it also applies to the number. Sometimes we make a mistake and we say, oh, that's not a variable, so this exponent doesn't apply. It actually does apply. You have to multiply it throughout. Okay, that was a mouthful, but it's quick revision. It's a revision that we dearly need when we look at these exponential equations. We cannot be able to be good at these exponential equations without understanding these basic laws, okay? It's also very important to understand in exponential equation, you will see it in an exponential form like this. You have to understand that it comes from there, okay? You see this, you have to understand that it comes from there, okay? So now let's go to the negative exponent. What did we say about negative exponent? We said if we have x to the n, if we change this power and put in the denominator, the sign of the exponent would change. As you can see there, we've taken it, we took it to the denominator with the divide sign. 1 would be left there. Remember, there's a 1 there. That's the 1. Okay, if we take it down, we will change the sign. Okay, if we go there, anything to the power 0 is 1. Very, very important. Okay, so now that we've done these, now we can move on to exponential equations.